Welcome to the soothing cosmos, where the wonders of the universe unfold in calm and captivating detail. Here, we journey beyond our world, exploring the mysteries of space, the beauty of distant planets, and the secrets written in the stars. If you enjoy traveling through the cosmos with us, remember to subscribe and join our voyage across the universe. Black holes for dummies. Few cosmic objects capture the imagination quite like black holes. They sound terrifying, mysterious regions of space where gravity is so strong that not even light can escape. For decades, they lived mostly in the realm of science fiction, but today, thanks to decades of research and even the first direct image, black holes are very real, very fascinating, and central to our understanding of the universe. In this chapter, we will strip away the myths, avoid unnecessary jargon, and explain black holes in a way that anyone can understand. A black hole is not a hole in the ordinary sense. It is an object with mass, sometimes more mass than millions of suns, compressed into a very small space. Because it is so dense, its gravitational pull becomes irresistible. Every object in space has gravity. The Earth's gravity keeps the moon orbiting us. The sun's gravity keeps the planets in place. But a black hole's gravity is far stronger than either of these. Cross too close to a black hole, and you can never escape. The boundary around a black hole where escape becomes impossible is called the event horizon. It is the point of no return. The most common type of black hole forms from the death of a massive star. When a star much bigger than our sun runs out of fuel, it can no longer support itself against gravity. The star collapses inward, and in some cases, the collapse is so extreme that it compresses all the material into a black hole. There are also other types. Stellar mass black holes, formed from collapsing stars. Supermassive black holes, millions or billions of times heavier than the sun, found at the centers of galaxies, including our own Milky Way. Intermediate black holes, mysterious and rare, somewhere in between. Primordial black holes, hypothetical ones that may have formed in the early universe. The name is misleading. A black hole is not an empty void, it is a region where light cannot escape. Because light itself is trapped, black holes appear completely dark against the background of space. You cannot see a black hole directly. What astronomers detect are the effects of its gravity, how it pulls on nearby stars, how it bends light, and the X-rays emitted by gas as it falls into the black hole. In 2019, the Event Horizon Telescope gave us the first ever image of a black hole. It looked like a glowing orange ring surrounding a dark shadow, the event horizon itself. Black holes are more than just heavy objects. They are laboratories of extreme physics. Spacetime curvature, according to Einstein's theory of general relativity, massive objects bend space and time. A black hole bends spacetime so much that it folds inward. Time dilation, near a black hole, time slows down relative to someone far away. For an outside observer, it would look like you freeze at the event horizon, never falling in completely. Singularity, at the center of a black hole, all the mass is thought to be compressed into an infinitely small point, where the laws of physics as we know them break down. These are not science fiction ideas. They are predictions of tested theories, though what actually happens at the singularity remains one of the biggest mysteries in physics. This is a question people love to ask. The answer depends on the size of the black hole. If you fell into a small, stellar mass black hole, the tidal forces, differences in gravity between your head and your feet, would stretch you apart in a process called spaghettification. But if you fell into a supermassive black hole, the tidal forces at the event horizon would be much weaker. You could cross the boundary without noticing anything unusual. Of course, you would still never escape, and eventually, you would reach the singularity. From the outside, though, no one would ever see you cross the horizon. To them, you would appear frozen in time, slowly fading away. Black holes have a reputation as cosmic vacuum cleaners, sucking up everything around them. But this is misleading. Black holes obey the same rules of gravity as any other object. If our Sun were replaced by a black hole of the same mass, Earth would continue orbiting at the same distance, and we would not be sucked in. The only difference would be that we would lose sunlight. Black holes only consume material that strays too close. In fact, they can coexist peacefully with stars, gas, and planets orbiting them from safe distances. In the 1970s, Stephen Hawking made a remarkable prediction: black holes are not eternal. Through a quantum process near the event horizon, black holes can slowly emit particles, what we now call Hawking radiation. Over incredibly long timescales, this radiation could cause black holes to lose mass and eventually evaporate. For stellar and supermassive black holes, this process is unimaginably slow, far longer than the current age of the universe. But it means that even these giants are not permanent. Black holes are not just curiosities. They play essential roles in the universe. Supermassive black holes anchor galaxies, influencing their shape and evolution. The collisions of black holes create ripples in spacetime called gravitational waves, first detected in 2015. By studying black holes, we test the limits of physics, probing where relativity and quantum mechanics meet. Far from being monsters lurking in the cosmos, black holes are key to understanding how the universe works. Let's clear up some popular misunderstandings. Black holes suck everything in. False. Only objects that come close are affected. Black holes are infinite. Not true. They are finite objects with measurable mass and size. A black hole near Earth could destroy us. Impossible. The nearest known black hole is thousands of light-years away. These myths survive because black holes feel mysterious and frightening. But science shows they are natural objects, governed by the same laws of physics as everything else. Black holes may be strange, but they are not magical. They are the natural outcome of gravity taken to its extreme. They challenge our understanding of physics, stretch the imagination, and remind us of how much remains to be discovered. For beginners, the most important takeaway is simple: black holes are real, they are not cosmic monsters waiting to devour everything, and they are central to the story of the universe. In the end, the mystery of black holes is not something to fear, it is something to inspire awe. Because somewhere out there, in the depths of space, these invisible giants are quietly shaping galaxies, bending spacetime, and writing the next chapter of cosmic history.